Hello guys, welcome back to the channel. Today we are going to talk about one of the most strangest objects in the universe called black holes. So they are often described as the objects which sucks almost everything, even light. Okay, and light is considered to be the fastest moving object in the universe. So it does not even let light to escape. So but the description of the black hole is often incomplete, and also sometimes it is slightly wrong. So today we will be going through in detail what the black hole really is. I won't be giving you the complete mathematics for the black holes. I won't giving you the what are the things about the black holes. But if you want that kind of video, if you want to know the mathematics involved into the black holes, like there are several kinds of black holes. We have stellar black holes, we have supermassive black holes, and then there are basically three types of black holes in the universe, which is described based on their mass. So now I will be coming on to that, um, but for this video I just want to make few things very clear. I'm not going to discuss the mathematics to study the black holes, but there are few uh, already existing mathematics to study the thermodynamics of black holes, to study the properties of black holes. And but I'm not going on to the mathematics part because it will be too much for, I don't know. And since we are just beginning in the we have just started creating such videos, so I don't know I should include all that thing or not. Anyways, I will be giving you the complete theory about the black holes, what this thing, what its properties are, and almost I'll try to cover everything theoretically. But if you do want the mathematics part, if you want to know what is the Kerr black hole, what is the Newman Kerr black holes, what how does the spin play importance in the black holes, how does the thermodynamics of a black hole affects, you know what are the factors affecting the thermodynamics of black holes, what are the no hair theorem. There are so many things. There are so many black hole model like BTJ black hole models and so many other kind of thing. If you want the mathematics of black holes, we can discuss all that too, right? But in this video we're just going to cover the theory part. So now coming to the point, what is the black hole actually? In simplest term, we can say black hole is a cosmic object which basically has such a huge amount of gravity, which bends the space-time curve, that it bends the space-time curve in such a way that it just attracts everything which is nearby it, and it keeps attracting it, and it keeps sucking it to the point which is called singularity. And now there is a whole process, right? So suppose if this is a black hole and this is a space-time curve, then black hole means it is having a very high, that means very it is having a very high mass. And since it is having a very high mass, it will just gonna distort the space-time curve to the very low because of its mass, because of its gravity. So what does that mean is it will just keep sucking everything around it. Okay, and there is a process, and there is a whole process how it is going to do that, and what are the whole steps involved into, like, getting everything into the center of the black holes. So we're going to talk about the process as well. Now, first and foremost thing, what are the different regions inside the black holes? And as I mentioned, black hole is basically a cosmic object which is having a very high mass, and having a high mass means it is having a very high gravity. Having a high gravity means it is going to distort the space-time curve to the very high degree, right? This is what all the black hole is. How it gets created, let's just talk about that. Suppose a cosmic body gets died, its life ends, right? So it will just die. Why it will die, it is again a very interesting physics, you should you should explore that, but I'm going to explain you that. Okay, so basically, suppose a star is about to die. So now it is facing two forces. One is, because it is from inside, it is facing the hydraulic pressure. What you say? Um, there is a intermolecular forces that is popping from inside, and then there is a gravitational pull that is uh, uh, that is acting from the outward, right? So it is just trying to make a balance from the outward, from the inside. So after a point, it cannot no more hold the balance of these two forces that is acting in opposite direction. So what it will do is, it will just expand, which is called the supernova explosion. Okay, it called the supernova explosion. Due to this explosion, sometimes what happens is, we get a very in that, like, cosmology sense, we say negative pressure, energy, and all that thing. So basically, that's how we start getting the black holes, right? Once it get died out, there is a very negative pressure, gravity, and all that thing. So we get the black holes. Once the black holes are created, it will just start sucking everything around it, and it will keep getting more mass, more gravity, and it will keep distorting the space-time curve more and more, right? This is how it is born. Now, what are the different regions of a black holes? Suppose a black hole is there. Suppose this is a black hole, and it has a very center point that is called singularity, which is the most center point of the black hole, and which is the most dense point in the black hole. Because as per the existing physics and as per the existing mathematics, we do not actually know what is the end of the singularity. Some physicists like Abhas Mitra, they have said, like, this is magnetically eternally collapsing object called MECO, where they have presented a mathematical model mentioning that, suppose, um, I'll try to explain you. Suppose this is a circular black hole. It has a singularity at the center. So this is, what Abhas Mitra did is, he kind of violated little bit of mathematics. What kind of mathematics he actually violated, I will discuss in another video. So he violated little bit of mathematics, and he tries to explain why the singularity is actually the magnetic eternally collapsing object. That means it will never actually die. It is just keep expanding. This is what his idea is. And then there are one of my favorite physicists, his name is Professor Leonard Susskind. He actually developed a whole new mathematics just to study the singularity, just to study the region after event horizon. And that's why I love him, right? The Professor Leonard Susskind is the Newton of the today's time, right? He's so genius. What he did is, he actually developed the whole mathematics to study this region, after the event horizon. Why that was so much necessary is because the existing mathematics cannot define the properties after the event horizon, right? Now, why it is not able to explain is because there are so many principles that happen. Suppose this is a black hole, this is a singularity. There is a region outside it which is called the event horizon. Event horizon basically means the area. Once if light enters into that area, it is no longer going to escape that origin. It is no longer going to escape that whole gravitational pull of a black holes. If you are going, if suppose if this is a black hole, if a light is coming, and if this is the outer radius of event horizon, once it gets inside it, it is not going back. This is the basic meaning of event horizon. So there is an outer layer. There are some theories that there is some chances that you can actually get away before the event horizon, but once if you get trapped inside the event horizon, you are not going back. This is what the event horizon is. It's basically like a safe boundary. Once you get inside, you're not going back. Once you are away, if you're like really a very superman kind, I don't know, but then there are some theories like tectons and some other there's a one Poincare conjecture and few other things where people have tried explaining that if some particle is able to, if if there is a possibility to escape black hole pool, then they can escape it before the event horizon, not after it. Okay, this is what the event horizon is. Before event horizon, there is a one more layer that is called accretion disk, which is just the circulating structure, or you can say the dust particles spinning around the black holes at a very high speed, like really very high speed. That is called accretion disk. And then we have, they have divided the accretion disk into few more regions. I'm little confused. I think they call it something like exosphere or something like that. I forgot the exact name, but basically it is divided in these many regions. Like we have singularity, then we have event horizon, and then we have accretion disk. And then they actually have divided that whole accretion disk into several regions based on the density and based on the kind of particles they are having there. This is what the black holes regions is all about. Now, why black holes actually matters, and what I believe is, if anything is there in the creation, it has a very important role to play. So you and like any random guy will be wondering what is the use of black holes if it just keeps sucking everything in. And basically it's just a giant black area which is not letting anything go out. And so what is the importance of such cosmic objects in the creation? So what scientists believes, what physicists believes, every universe has a black holes at the center of their galaxies, um, at the center of their galaxies. And we also have, like our Milky Way galaxy have a one super massive black holes at the center. And people try to study that supermassive black holes through the CMB cosmic rays. Basically they are like cosmic rays, and they try to study it because there is, I don't, because we cannot study the supermassive black holes which is present at the very center of our galaxy. Our galaxy has a several solar system, then we have our solar system. So basically, what physicists believe is every solar system or every galaxy, I'm sorry, like every galaxy have a one supermassive black holes, which helps in creating more solar system, which helps in creating more star formation and so many other things. So this is why the black holes matters. And also they are responsible for destructions of so many solar systems, and they are also responsible for creating so many solar system and star formation. This is what the scientist believes. So basically every galaxy have a supermassive black holes. In our solar system we may not even see any black hole. Think about this. Like in our solar system we have 8 planets. Pluto is, again, we are having a debates on it. In our solar system we do not have any black holes. Okay, what will happen if we get even a one black hole, suppose in the region of Oort cloud? Okay, Oort cloud is the region which is too far from our solar system. It comes behind, way behind Pluto, right? If we encounter any black holes in the region of Oort cloud, it is going to affect our solar system in so many ways, like in so many ways. And the moment it will come little bit more closer, I think our life will start affecting in significantly, and we will be having consequences if it keeps coming closer to our solar system. So you can understand, when I'm talking about a very small black hole coming into our solar system and can affect us in so many ways, then you can think about what is the power, and basically what to say, like what, how a supermassive black holes would be affecting our galaxy, right? So this is what all about the black holes. This is super interesting topic. I could get you more details, but I think this is going to little long, and I don't think people will watch it for so long. So I'm just trying, so I will be ending this video here. Let me know if you want to know the whole mathematics of the black holes. I will just try to start from the thermodynamics part. I'll start discussing very random, like Shaw's child black holes. That is a very, you can say, like if you want to start studying about the black holes, you should start with shows child black holes, because it does not have any spin. It is just like a normal standard general black hole. Okay, that what we see and what we know about black holes. But then there are levels to that. We have BTJ black holes, we have Kerr black holes, we have Kerr Newman black holes, and then there are other types of. So if you wanna study about black holes in detail, let me know, comment in the section, get this video more views, and I'll try to figure out. And I'll like we'll start making this whole channel into educational videos, and I'll start like we'll start discussing about the mathematics of black holes. This is very interesting thing. Like, you will understand what I'm talking about when Professor Leonard Susskind came up with the mathematics for which he got Nobel Prize. He actually developed the whole mathematics where he described how space-time gets distorted after the event horizon, and he tries to explain certain things inside that. Just to give you a little idea, there is a one theorem called no-hair theorem given by Professor Stephen Hawking. He tries to explain the thermodynamics, okay, using the no-hair theorem of the black holes, but it was too general that we cannot apply that whole principle to almost every black holes. So that's where Professor Leonard Susskind came. That's where now one famous physicist called Poincare, where he came and he tries to explain that whole thermodynamics and that whole uh, properties of black holes. If you want to know all that thing, it involves little bit of mathematics. So let me know if you really want to know all that thing, and if I get like really good amount, and then we're gonna geek about it and we're gonna discuss all that thing. It would be so much fun if you guys like want to know all that thing. And so no, like, it would be so amazing to know what the Professor Leonard Susskind have done to study the whole uh, black hole mathematics. What is the BTJ black holes? What are these things? Like, what are the properties? What are the major mathematical models to study the black holes and all that thing? We're gonna discuss all that. But I just need to have I need like really good views and really good subscribers, so that I can have a little bit confidence. Okay, let's just make it. Yeah, this is all about this video. Let me know if you have any questions, or if you want to have anything to discuss. Let me know in the comment section, and please subscribe to the channel. Bye bye.